Okay, so we've done the 5 card hands in poker. We've done a couple examples. Your homework uh, after this section 113, 1 to 9, 11, 13 to 15, 17 to 19. And we're just going to continue on with some more uh, problems and situations where order does not matter. So, a dance committee of 7 students must be chosen. 3 students from grade 9, 1 from grade 10, 5 from grade 11, and 2 from grade 12 have volunteered. How many ways can this committee be formed if it must include at least one grade 9 student? So if it's an at least question, you're going to go with one grade 9 student or 2 grade 9 students or 3 grade 9 students. And you got to break it down that way. Now, dance committee, so there's no order because there's no president, vice president. It's just 7 people on the committee. And how we break this down, you'd want to break it down first by grade 9s because you're going to need to know how many grade 9s because it's an at least about grade 9s. And then you'll fill up the rest with 10s, 11s, and 12s. Does not matter how many grade 10s, 11s, or 12s, so you can put them all into one group and kind of solve from there because they don't ask about specifics. So let's see how we break this down. There's 3 grade 9s, 1 grade 10, 5 11s, 2 12s. So you can do case 1 grade 9. That is 3 choose 1. And then how many others are left? There are 8 others, and you need 6 of them. So 8 choose 6. Or 2 grade 9s. So that's 3 choose 2. 8 others, and you only need 5 of them this time. Or 3 choose 3. 8 others, you need 4 of them. All right, it's an or question, so you add them up and get the answer. The other way to solve this is indirect. So if you want at least 1 grade 9, you could do it as all possible, so no restrictions, all possible, minus no grade 9s. All possible, or the total number of committees minus the ones with no grade 9s, will give you at least 1 grade 9. So you have to go back and figure out how many total number of committees could be possible. There were 11 students total when you added up the 9s, 10s, 11s, and 12s. And you need 7 of them for the committee with no restrictions. So 11 choose 7 is all the possible groups. Minus committees with no grade 9s. Remove the 3 grade 9s. You have 8 left. Choose 7 of them because you have 7 in the committee. And that gives you the same answer of at least 1 grade 9. All right, a couple interesting ideas, kind of variations on the idea of what we're doing. So artist has an apple, an orange, and a pear. In how many ways can the artist choose 1 or more pieces of fruit for a painting? So think of it as yes and no. The artist has an apple. Are they going to use the apple or not? Are they going to use the orange or not? Are they going to use the pear or not? So these are distinct objects, no similar items. They're all different. Apple, orange, pear, all different. Choose or don't. 2 ways of doing that. But if I said no to the apple, no to the orange, and no to the pear, I would have nothing to paint. So you can't have nothing. So remove that no, no, no question. That's the null. This. Got to subtract that at the end because you obviously have to paint something. So saying no to everything doesn't work. So 2 options, yes or no, times 2 options, yes or no, times 2 options, yes or no. but subtract the no, no, no answer. And that'll work if you have even more options. It'll be 2 to the power of the number of options you have, the number of items that are distinct, and then you subtract 1 at the very end. So there's the formula. If it's distinct items, you need at least 1. Yes or no to all of them. Subtract 1 at the end. Subtract the null set. No elements is the null set. All right, last few examples here. School librarian has enough money to purchase some new books. Staff have put it in requests for 3 dictionaries, 6 English manuals, 2 copies of Romeo and Juliet, 1 history of math book. How many different purchases are possible? So in this scenario, we have repeats. They're not all distinct items. There's repeats of certain items. So not all distinct. Some of them are similar. They're repeats. In the dictionary combination, you have 3, but you could choose not to have any dictionaries. So that makes 4 choices. English manuals, you have 6, but you could choose no English manuals. That makes 7 choices. Romeo and Juliet, you have 3 because there's 2 copies, plus you could choose none. And then math, you could do 1 history of math book or none. So there's 2 choices. Of course, if you said no to all of them, you would not have any actual order. You'd have 0 books to buy and you'd have 0 orders to make. So that's not an option either. So you have to subtract 1 because the null is not valid. So 4 times 7 times 3 times 2 minus the 1 at the very end. So generalized formula, it's the number of repeat items plus 1 times the number of repeat items plus 1. Keep going on all the different repeat items and then subtract the null at the very end, and that'll give you situations where you have some distinct items, but there are repeats of those distinct items. All right, last one here. Patty wants to throw coins in the Trevi fountain. How many different sums of money could she throw if she has 1 penny, 1 nickel, 1 quarter? So again, she has the use of the penny or not, the use of the nickel or not, and the use of the quarter or not, but you can't throw nothing into the Trevi fountain. You have to have different sums. So the null is not an option. So you've got yes or no to the penny, yes or no to the nickel, yes or no to the quarter, 2 to the power of 3 minus 1. And then the next one, 4 pennies or 0 pennies, so that's 5 options. Nickel, you have 2 options. Quarter, you have 2 options. Subtract the 1. Suggested questions, page 120, 115, and 18. I will post some review for this unit as well on D2L, and you can expect an assessment next week. Then we have a few more things to cover before the end of the semester, but kind of chugging along here. So review and an assessment next week.